Hi, Chris Kuzmal here. Today we're going to contemplate how to create problems involving integration which are solvable using substitution. So notice that this is slightly different than solving problems using substitution, although it will help you with that. So consider the integral of g of x times f of g of x dx. If we let u equal g of x, then du is g prime of x dx, and therefore dx is du divided by the derivative, okay? That means that when we do the substitution into this particular form here, we already have the derivative here, and so f of g of x becomes f of u du divided by g prime of x, and so the g primes cancel. So because we have a g prime inside of the function, and so we have a g inside of the function and a g prime outside of the function, and they're multiplied, then those g primes, those derivatives will cancel, and the result will just be the integral of f of u du. And so if f is integrable, then we're in great shape. That's all we really need. All we need is for f to be integrable. All right. Well, x, the function f of x equals x, is certainly integrable. So let's choose a g, as long as g is differentiable, and usually, generally speaking, almost any function is going to be differentiable. So g of x equals sine of x. To integrate the problem then that we're going to set up from these two functions is to take the derivative of g and multiply it by f of g. Well, the derivative of g is the cosine of x, and f of g is, x of sine of x is sine of x, because x is the identity function. It's so simple, it's a little bit hard to understand. What is x of sine of x? It's just the sine of x. Okay, so this is our problem. Integrate cosine of x times the sine of x. Because we know what f and g are, we know what the substitution ought to be. The substitution ought to be that u equals whatever g of x is, which in this case is sine of x. So when that substitution happens, the integral becomes cosine of x u du divided by cosine of x. In other words, we cancel everything and we end up with an integral of u du, which is the same form of f, the integral of f of u du, which in this case, because f of x is x, f of u is u, so the integral of u du is the problem that we have to do. That's so easy. That's u squared over 2 plus a constant. All we do is substitute in for u, which was the sine of x, and the answer is 1/2 sine squared x plus c. Okay, now we're going to use this to blow your mind, by the way, because now we're just going to change this g of x to cosine of x, set up the exact same problem, almost. There's only a slight difference is we've reordered. Oops, went wrong direction here. So we had this problem. Now we created this problem. I toggle back and forth between them. We see g of x changes from sine of x to cosine of x. And the way the problem setup changes is simply that we swap the sine and the cosine, and we reversed the sign, the positive negative notion of sine, not the trigonometric notion of sine. And so the problem we're supposed to solve is the integral of the negative sine of x times the cosine of x. And that just seems so similar to this problem here. It's just a negative sign, and the negative sign can be pulled out of an integral. So why do we even have to bother? And we can't, we don't. And yet, if we follow the process, where now u is the cosine of x because g of x is the cosine of x, that means that the negative sign is going to cancel, and we're going to, once again, integrate u du, because f of x is x, so f of u is u, and so the integral is u squared over 2. And so we substitute in for u, and we get cosine squared of x. So think about that, and just keep in mind the trigonometric identity of the sine squared of x plus the cosine squared of x is 1, and that will help you, I think, realize why we can have what seems to be the same basic problem come up with what seems to be different answers.